On to question 10. With the function that's given, you're given the information that x minus 1 is a factor and that x plus 2 leaves a remainder of minus 3. So I set up using the factor and remainder theorem. X minus 1 is a factor, so f of 1 is 0. X plus 2 gives me f of minus 2 is a remainder minus 3. So substitute the appropriate value in. Each gives you a relationship with p and q, which you will solve to get p is 1 and q is minus 5. So factor remainder theorem for part A. Part B asks us then to factorise it. A number of ways in which you can do this. This is the way that I would go here. I know it's a x minus 1 is already a factor, so I've got that. I know that the other factor then has to be quadratic, so I can set it up with x squared. I know it's x squared because it's only going to be 1x cubed, bx plus c, and I can then see what I need to have in this situation. To get minus 5 at the end, I know minus 5 comes from doing that multiplication there, so I can see that that has to be plus 5 in that position, so that when I multiply this out, I get minus 5 as I needed. The b, let's put this in as plus bx, and I need to just think about how I get particular terms. I'm going to look at how do I get the x terms here. So to get an x term, I would be doing minus 1 times b, so that's minus bx. But I'd also, of course, get x terms from x times 5, so plus 5x. And I know that that has to match 1x. So I can see from here that the x's can cancel, leaving me minus b has got to be minus 4. So b is 4, and so I can factorise that. The b then I can know has got to be 4x. So I can factor that to get the result on the mark scheme there. Then the sketch. I've got my calculator to do all of this for me, so bang that into your calculators. Make a note. I think it particularly asks you for the maximum and the minimum points and the x and y intercepts. So I should also be making sure that that's labelled as 1, nice and clearly, minus 5, and then the max and the minimum there. Part D, use your graph to state the range of values of c for which f of x equals c has at least 2 real roots. Well, I can see if f of x equals this number here, it will lead me to 2 roots, a repeated root and a root there. Anything through here gives me 3, that's fine. Of course, I'm going to go all the way down to this point where I'm going to get a root there and a root there. So I can see that c can be any value as high as this number here, which corresponding to the y coordinate of the maximum, and down as low as this number here. So I can set that up, the appropriate interval, knowing that I'm allowing these points, because if it equals that number, I'm going to have 2 roots, and the question asks specifically for at least 2. So there's my interval required.